Okay, and this is a hardware ladder circuits, and this is a PLC language. So we can see it's similar. It's similar. This is last week I told you, and another is such as this. Let's look at this picture. And this is what? This is a Boolean program. This is a Boolean program. And this program similar to C or C to some computer language. And the first is LD10. What means LD10? Do you have remember what I have
Load, teacher.
Introduction to you last week? LD10. What is LD10?
LD is load, teacher. It will load.
Yeah, such as this, I will sorry, I will give you some. Such as this is a stack, and when we'll do this one, and the top layer is what? Top layer is what?
10.
10.
Yes.
Yeah, 10. So, and OR20, and the OR20 is what? And when execute this one, and this stack is changed to what? Is changed to what? Ten
Or 12.
or 12. And this is plus is means or. This is means or, and the multi is means and. Multi is means and. So we can see ladder or load 10 or 12. It means this. It means this. And when we execute this program, this stack is changed to what? Is changed to what? Is changed to
dot.
is changed to sorry, it's not difficult to draw this picture. Okay. Okay, this is because 10 and 12 is all, and the result is and 11. Do you know? Such as this picture, such as this picture. And the last one is out. Out is means and just equal. This is what I have told you last week, and I will share the picture, the PPT about the last week. So, and the last week I will introduce the what? What?
Could you please allow us to record the class?
Can you tell me again? Say again.
Could you please allow us to record the class? I want to record this class.
Yes, I will record. I will record. I have a record. Including.
Yes, Laushi, you are recording, but I want to record.
Okay, you want to record?
Yes.
Okay. So I will. Okay. So please. And uh, how can I record? But I have record these scars and
Okay, teacher, after class you can send this record to us.
yes, I have a and I have a recorder. I have a record these scars and after these scars I will give you the film.
Okay, okay, teacher.
By QQ or in the cloud in the cloud
Okay.
in the
Laushi,
cloud
everyone
ওই সমস্যা নাই
doesn't have
হাসিব
to.
যাবে যা
in
অনেক
the
কুইক
cloud
দে
in the cloud in the cloud.
ওকে টিচার ওকে প্লিজ কন্টিনিউ
So last class I will introduction something about the stack because this stack is a tool to understanding STL language. Such is STL language. If you didn't know the stack, if you didn't know the stack, and you didn't know the STL language. So last week I will tell you something about this. And I will go on and according to some example. Now let's look at this picture. And in this picture, we can see this is LAD language. And in this LAD language, we can see this is what? This is what? This is the I 2.00 and I 2.1 and the results or what? Or I 0.1 and this result and what? And this one and the final results is equal what? Is equal Q 5.0. Do you know? So this language is equal to what? Is equal to this. So I will explain by the stack. So I will explain by the stack. Let's to see. And when I do this one, the stack change to what? Maybe the initial is this. Initial is this. And when we do this one, and the stack, the top level. The top level is what? The top level is I 0
0.0.
x 0. The top level is, and this is what? This is x1, x2. So if we do this one, this stack change to what? This stack change to what? Is change the top
I
is
0.1.
I 0.1 and the second is I 0.0 and the other is this. Do you know? And when we do this one, this stack change to what? Maybe you have learned. And the top is what? The top level is what? I 12.0 and the second is I 0.1 and the third is I 0.0. And when we do this one, this stack change to what? This stack change to what? This stack change to what? Change to I
2.0
2.0. And this is what? And. A is means and. So and I 12 or 2.1. And this is what? I 0.1. And this is I 0.0. So if we do this one, and this stack change to what? Maybe we can see this this one. Maybe we can see this one. This is what? OLD or the top two stack values, because means this and this one is all. The result is to what? Is to here. And another two going up, and other two going up. Do you know? And ALD is what? ALD is the end, the top two stack. It means the top level and the second level values is end. And the result is in what? So these two and the result to what? To here. And another two going up. Do you know? So if you have learned this, can you tell me if we do OLD, this is this stack change to what? If we do OLD, to OLD. And this stack change to what?
It will be I 2.0 into I 2.1 plus I 0.1 0.1
I and 2.1. And the OLD is what? O what?
plus teacher
O I
0.1.
0.1. So we can see the first level. This one. First level is what? This. Do you know? So the second level is what? Second level is I 0.0. Because this is what? This is what? This is this two. This two. The O results is here. Do you know? So another two going up. Another two going up. So this is okay. And so this is the I 0.0. So this is what the OLD. And can you tell me when we do this one? When we do this one, and this stack will change to what?
It will
Change
be
it to what? Change it to
add
the
to
top.
the second
The top
step
is what? I
2.0
2.0 and I
2.1
2.1 and I 0.1 and the results is and what?
and
And
0.0.
I 0.0. Sorry, this is Andrew. So this is what we will tell you. And if we can see this, if we can see this, the ladder language, I 2.0 and I 2.1. This one. And I 0.1, this one. This is and the result is O and what? And I 0.0 and the result to what? The result to what? To Q 5.0. This one. So this is what the so this is what the ladder and the STL language. So in this one, so this is another example, and you can try to draw this stack to understand this language, and I will give you 5 minutes. And to try to use this stack. This is stack. Use this stack to understand where this TL language is equal to this lead. I will give you 5 minutes to try. Do you know? 5 minutes. After 5 minutes, I will conduct this one. Conduct this one. Hello everyone. I will go on, and I will look at this one, and I will look at this one, and this is one, and we can see it's I 0.5, I 0.6. This one is what? Is all, and the result and this one to what? To Q 7.0. So I will look at this STL language, and when we do this one, and the stack is changed to what? The stack, the top level is I 0.0, and we do this one, LPS, and what is LPS? And we can see this one, LPS. LPS is what? Logical push. What is copy the top level to what? To second level. Copy the top level to second level, and the other is going down. So we can see if we do this one, the stack is changed to what? Can you tell me? The stack is changed to what?
I0.0 and again
The
I0.0.
top level is 0.0, and the second is 0.0. Okay? And when we do this one, the stack is changed to what? Change to what? Change to I 0.0 or 0.5, sorry, 0.5. And this is I 0.0. And the third is I 0.0. And when we do this one, and the stack is changed to what? This stack changed to what? Can you tell me? Change to what?
I0.6 plus I0.5
0.5. Or what? Or
plus
I
or plus
0.6.
0.6.
Okay. And the second is I
I0.0
0.0. And this is I 0.0. So we can do this one, ALD, and this stack, is changed to what? Change to what? Yeah. Okay.
into
So the top
I0.0.
level is changed to what? Is changed to I 0.5 and option or I 0.6 and what?
And
And I 0.0. And when we do this one, it means what? It means Q 7 0.00 equal to what? Equal to this one. Equal to this one. So we can see this STL language, this STL language is equal to what? Equal to this one. So we can do this. So this is equal to what? Equal to this one. Equal to this one. Equal to this one. So this is the relationship about STL code and ALD network language. So the ability to translate from ALD network to STL code, or translate from STL code to ALD network, the ability you must to have, because in the end of my class, the testing where to do something about this. So you must to have this ability to translate the STL code to ALD network. Do you know?
老师，
Okay.
老师 when to use this LPS, LRD, and LPP？ 老师，我们什么时候用那个
Pardon?
LPS、LRD 和 LPP？ 下面我们没用那个
because
LPS， 然后下面我们用了 LPS， 还有 LPP、LRD。
because this is because when we do something programming about PLC, maybe you can use two type or two method to programming. Do you know?
Yeah, like converter.
You can use two type programming language, but some engineer, he is suitable for LD network, or suitable for STL code. But as a student, you must to learn to type. To type, you must to learn. Do you know? Maybe in some high computing, in some high computing, maybe STL code is easy to programming. But when we do something about the logical controller, maybe ALD network is easy. Do you know? Do you know?
Yeah, Losh.
Okay, so I will go on. So this is what I will tell you last week and this week. And I will go to the chapter 4. Chapter 4. Chapter 4. And maybe chapter 4, some picture is in Chinese. So if you have some question, you can use translation software to do this. In the chapter 4, I will introduction something about experience design method for PLC. PLC language, PLC programming technical includes experience design method, logical design method, cycle diagram design method, and sequence function chart. Maybe we must to learn the two method, read text, experience design method, and sequence function chart design method. These two methods you must to learn. Do you know? So I will introduction something about experience design method for PLC. Can you see this network about
Yes,
the
teacher.
ladder network? And in this network, we can see it means start, hold, stop programming. Do you know? It's a start, hold, stop programming. Because in this network, what is the start? Start is what? Start is
X0.
what? X0. This means start bottom. This is means start bottom. And what is the stop? This one.
X1.
X1 is means the stop bottom. And this is what is a hold? What is a hold? This one. This one. This is means hold. Because when we see this is X0 and or this one and or X1 and equal to what? Equal to Y0. And we can see when X0 equal 0 and XE equal 0. Y0 equal to what?
It's 0.
Can you tell me?
Because
When
close.
X0
It
what?
will be
Close.
0, teacher.
X1.
Equal to what?
0.
Equal to what? 0. Okay, 0. Why? Because X0 is equal
Close.
to
Close.
0. So this note is not so we can see maybe x1 equal to 0. So this node is what? Is
1, teacher.
yeah. I will use some translate software. Sorry. conduction 导通是吧 ？open or conduction 是吧 ？OK， maybe x00 is maybe x00 equal 0. So this node is not conduction, but x10 equals 0. So its node is what is conduction. But because this not conduction and this conduction, so y0 equal to what? Equal to 0. But when x0 equal 1 and x1 equal 0, y0 equal to what? Equal to 1. Because this node is conduction and this node is conduction. So y0 equal to 1. Do you know? Maybe use x0 is a button because button is only conduction for a few minutes. So maybe the x0 equal to 0. How to hold y0 equal 1? Maybe we can use this note. Because we can use this series signal. We can see when I maybe this I 0.1, maybe this I 0.2, and this is Q7 or 5 or 4.0, and this is Q4.0. So we can see when I 0.1 is 1 for a few minutes, and maybe I 0.2 is 0, so this conduction. So Q5 of Q4.0 is 1. But when I 0.5 is changed to what? Is changed to 0, because this is 1. So maybe we can use this to conduction to Q4.0. So this one means hold. Okay. This is the start, hold, stop programming, and the something about we can use to control a model. To control a model, we can use this program. Start, hold, stop. Maybe we can see this language. Can you tell me this language function? What is the function of this programming? Can you tell me the function?
Header diagram.
Maybe we can see this. We can define. We can define
So
Y
y1 is equal
is
Y1
a
is
model. Okay, you can tell me what? You can
y1
tell me.
is equals to x1 plus y1 into x3.
Next three. This is next three. Okay. I will give you some example. I will give you some example. Such as this is maybe it's not maybe it's not good. It's not good. This is model 1, and this is model 2, and this is what? This is sorry, I will use translate software. Cabinet belt. I can use this one. Conveyor belt. Conveyor belt. Do you know? Conveyor belt used in some factory.
Conveyor belt.
Conveyor
Conveyor belt.
belt. Conveyor belt. And the conveyor belt is what? Is to translate something from here to another. Maybe this is a direction of the material, the relation from here. The relation is from left to right. So can you tell me if we have this one, have this one, have this one, have this one, have two belt, have two this belt, and motor 1 and motor 2, which one will start first, or which one running is the condition another? Can you tell me which one will first starting? Which one? When material from left to right, which one? This motor is
Right.
M1
Right
teacher.
one.
motor 1 or motor 2
Left.
is
Motor
first
1.
to start. Is the first to start.
2. 2 or
Left to right, it's motor 2. Yeah. Yes.
Yes. Why? Why?
because
Because it's
left to right
left to right.
need to go.
Yes, maybe the material come here. Maybe this one is running. So this one is not running. So the material come here is to what? I will use language translation. Maybe the material will pair up in here. Will pair up in here. So this one must to start first, and maybe motor 2 is stop. Maybe motor 2 is stop. The motor 1 must stop. It's right?
Yeah,
It's
that's
right? Okay. So we can see this language is to use to control these two model, and why y1 is y1 is what? Y1 is model 2, and Y2 is model what? Model 1, and this is model 1. This is model 2. This is model 1. So we can see. When we will start model 1. When we start model 1, and the start button is what? This is start button.
X2
This is start button,
and hold
and this is a stop button. So when we start model 1, must be what? Must be model 2. Sorry, must be model 2 is running. If model 2 is not running, the model 1 we can't start it. Do you know? So this programming is for this case. For this case. Do you know? Do you know? So in this programming, we can see the Y2 running. If we will start Y2 running, use this button. Maybe Y1 must be running, so we can start Y2. Do you know? Okay. So I will give you some minutes. Can you see this language, and you use this language to the series value y1 and value y2 to do this. Give you 5 minutes. Give you 5 minutes. 你们自己画一画，对，你们自己画画，根据你的时序，能不能画出来啊？ Hello everyone. I will discussion this example.
Yes, Lordship.
Okay. We can see from here. Maybe when x1 is what? Is equal to 1, equal to 1, equal to 1, and x3 equal to what? Equal to 0. So we can see this node is what? Is conduction. Is conduction. And this one is what? Is conduction. And y2. Y2, this is initial value is 0. So this node is conduction. So y1 is equal to what? Equal to what? Equal to 1. So we can draw this picture, this one. But when x1 is to 0, but maybe y1 is 1. So we can use this to hold y1 is equal to what? Equal to 1. So y1 is equal to 1 is equal to 1 to what? To here. When 0, when this one, when this 62 is equal to 1, equal to 1 is this conduction. And this x4 is 0, so this is conduction. But y1 is equal to 1, so it's not conduction. It's not conduction. So y2 is 0. Y2 is 0. So we can see this y1 is equal to 1 and hold equal to 1 this. And when x3 equal to 1, so it's conduction. So its node is not conduction. So from here, y1 is to 0. y1 is to 0.
And again,
y1 is to 0. You know? But we can see this. We can see is y2. Y2, maybe we can see when 62 is equal to 1. 62 is equal to 1. But here maybe y1 is equal to 1. So x2 equal to 1. So y2 is not equal to 1. Is to here, is to what? Is to here. To here. To here, when y1 is equal to 0 and x2 is equal to 1, so equal to 1, and it will hold. It will hold. And when x4 is equal to 1, and this is not conduction, so it will go down to 0. So this is the result, y1 and y2. Do you have some questions?
No, Lordship.
Okay.
But Lordship, x4, when x4 and xy, I mean last one maybe 1.
What?
When x4 close. X4 line.
What? This
X4.
X4. Okay, X4. X4 and
X4 line.
what?
X4 line dependent y1 result. Yes, Lordship.
Y1.
Maybe
Maybe
here
Y1.
one.
Maybe is this, and this is right. Do you think this is right?
It's right, but this is right, but I'm confused little here. Just x4 and x1 result is last one.
Last one.
Last maybe one. I feel just like this. Maybe I'm not sure.
Okay. Because I will give introduction this programming, because this is interlocking. Do you know interlocking? Interlocking. Y1 and Y2 is interlocking. What it means? What it means?
It means Y1 and Y2 are dependent on each other.
It means what? It means when I will start Y1
One and also is
and Y2 must be stop. It's not running. Maybe Y2 is running. I can't start Y1. Do you know? And another other hand, when we start Y2, the Y1 must be what? Y1 must be what? Y1 must be stop. Do you know? Maybe
Yes,
we
boss.
can see. Maybe we can see this example. This example. Maybe we can see as example. Maybe this is a belt, and this model. This is a model. This is a model, and sorry. This belt can forward rotation, forward or upward, forward or reverse, reverse running or forward running. Do you know? Its belt can this belt can from left to right or from right to left. Do you know? Maybe the signal Y1, the signal Y1 to control the motor from left to right, and the signal Y2 is to control the motor, is to control the belt from right to left. So this signal is impossible to equal one in the same time. Do you know? In the same time, this signal, these two signal Y1, Y2 is impossible to equal one in the same time. Do you know? So we can use this program to control the belt running from left to right or from right to left. Do you know? This signal to control the belt from left to right, and this signal control the belt from right to left. Do you know? So we can use this. This means interlocking. Do you know? Okay. So this is something about the experience design method. And this is means what? Means two motor. There is a series. There is some this one master first order, and this is the second order. Do you know? Maybe this one we're running. The Y one must be running. Do you know? So this is something about the experience design method about PLC. Maybe you can see this one, and this one is and this one is different. Is a different to this. Is a different to this. And can you tell me the function? Can you tell me the function of this programming? Give you 1 minute to thinking. And I will discuss in this example. So as we know, Y1, this is what? It's a button for start for Y1, the start button for Y1. And this is what? Is a stop button for Y1. And this is what? Is for hold for Y1. And this is what? This is a start button for Y2. And this is a stop button for Y2. And this is for hold for Y2. And this is what? And this is what? Yes, it's interclock, but this is order order clock. Maybe if we will start Y1, the Y2 is must stop. But we will start Y2. Y1 must running. Y1 must running. So this is what this programming, and I will give you another example, and this programming is to control a motor, to control a motor. To what? To control a motor. to control a model, and and this is for a button to control the model to forward running, and this is a start button for the model to resolve running, and this is a stop button, and this is a stop button. This is stop button, and this is a yes, this is a stop. What? Okay. Oh, sorry. I will. And this one is a start button for forward running for the model, and this is for stop button, and this is for stop button, and this one is interclock for start button interclock. And this is for the state running state interclock. So we can see in its proc this two interclock. It's a start button interclock, and it is the state interclock. So this is for the motor control for forward running and resolve running. And this is for a timer. And the timer can used for to some signal such as sorry. Some square wave. We can use the timer to square wave to generate square wave. So I will give you some example. And in this example, we can see this is a node. This is a node 1M0.00. When this one is 0, and this node is conduction, so its timer. So its time is a start. When the time is to 100 times 10 microsecond, it means 1 second is 1 second. So we can see when the time is to here, it's time to here, and the T33, but we can see T33 when the number is more than 40, Q000 is what? Is 1. And when T33 maybe it's time to 17. T33 is 1, and this is conduction. So M0 to 0 is equal to what? Equal to 1. So its node is not conduction. Is not conduction. Is not conduction. So we can see the T33 is 2, 0. So it's 2, 0. So by this means we can generate a square wave. Square wave. This is what I will told you in this course. In this course about the experience method for design a PLC. For design a PLC, and you can after this class, you can to learn. You can to learn by the file I have give you to learn what is the timer, TON, the timer, TON. What is the timer, TON? You can use the file I have give you. I have give you. So I will share the file. Share the file. Share the file. Can you see this file? Can you see this file? And in this file, I will see here.
Also, we cannot see the file.
Oh, okay. Yes, it's not this file. Sorry, it's not this file. Not file. Not file. Sorry. Wait for a minute. Wait for a minute. For a minute. Yes, you can see this file. I have give you. I have give you, and we can see something about the program introductions. Program introductions, and in this one, you can see what? You can see. Sorry. Is a timer programming info. Okay, this one timer. Okay, this one timer. After this class, you must to read. You must to read this file about the timer. And the timer is including the type TON, the type TONR, and the type TOF. And after this class, you maybe to see this file, to learn this part, And the next class, I will discussion the timer instructions, Do you know? Okay. Maybe the class this week. The class is over, and I will continue next Monday, next week in Monday. See you next week. Bye bye.
Okay, Lavshi, bye bye. See you next week.
Bye bye. See you next time.